In this example, we're going to demonstrate how to use the passive sign convention, the equations for power, and the power balance to calculate an unknown element. Basically, the power to an unknown element. This is actually our first tool that allows us to analyze a complete circuit like this. You'll get a lot more later. But previously, you've only been working with like single elements. So power balance says that the sum of power is equal to 0. So we can write that as the power of A plus the power of B plus the power of C plus the power of D, all equal to 0. And then we can calculate the power through each of these elements and then put them all together. So we don't know what power A is. We don't have voltage or current defined for it. Power through B, so again, we're going to be using power equal to plus or minus IV. Just the plus or minus again is to tell us to get the sign as we go through there. So the arrow picks up the positive sign. Our current is 8. Our voltage is 12. That's going to give us a 96 watts. Power through C, our arrow is going to pick up a negative sign as it enters. Our current is -2, and our our voltage is 10. So those negative signs are going to cancel out. We're going to get a 20 watts. And then for D, we enter through a positive sign. Our current is a -8, and our voltage is a 2. So that is going to be a -16 watts. So we have a passive element, and an active element. When you put all this back together, you get power A plus 96 plus 20 minus 16. All it has to balance out to 0. So when you solve for power A, you're going to find that it is -100 in order to balance out the circuit watts, which means that power A has to be some kind of, probably a supply, some kind of a source, because it's active, because it is negative power, and we assume that passive elements are positive.